Okay, I thought it might be helpful if I made a series of videos that are related to the second graded homework. I'll analyze a different model, but I'll go through in an analogous way and talk about it. So suppose we have a circuit that has a DC voltage source, 5 volts, we have a 200 ohm resistor, and a 3 microfarad capacitor. First, let's get our differential equation for this. So using Kirchhoff's law, just voltage law, going around a circle there, we have 5 volts. Then we drop 200 ohms times I, right, IR. Then we would drop Q over 3 microfarad. Right, so this is our Q over C. This is our IR, and this is our battery. And the sum of all those gains and drops needs to be 0. So let's do a couple of things to clean this up. We'll drop the units for now to make it a bit more convenient to work with. So, and we'll write I as a derivative of Q. So this is minus 200 dq dt. And then also let's take this number, which is 3 times 10 to the minus 6, and that's on the denominator, so that's going to end up being 3 times 10 to the 6 here, times q equals 0. And the first thing we're going to do, the first thing I ask you in your homework, is to do a flow on the line for your differential equation that has numbers. So we'll do the same thing. So let's try to solve this. This would be dq over dt. Let's see. You'd have a 5. You'd have a minus 3 times 10 to the 6 q. You're going to divide by 200. There we go. I think that's right. All right, moving the derivative over, divide by 200. Okay. And let's see. Let's simplify this a little bit. 5 goes into 200, 1 over 40 times. And then those two zeros knock it down to 10 to the 4th. So we'll have 1.5 times 10 to the 4th q. All right. So let's do our flow on the line there, and we'll use it to sketch solutions. Now, as soon as you know separation of variables, you could solve this equation explicitly, but you're not asked to do that in the homework yet. So we'll do q prime versus q. This is a line. It has a negative slope and an intercept. Now, don't get overly worried about your scales. You know exactly what this thing looks like. You don't have to puzzle over how you're going to graph it. This is the 1 over 40. And then we can find what this equilibrium has to be. That's when q prime is 0, or when you have 0 equals 1 over 40 minus the 1.5 times 10 to the 4 q. So let's see, move this stuff over and then divide. So it's 1 over 40 times 1.5 times 10 to the 4 equals q. What's that? See, 4 times 1.5, that's 6 times 10 to the 5th. So this is going to be 6, yeah. Well, it'll be 1 over 6 times 10 to the minus 5th. So what's that? That's like 0.167, say, equals q. Of course, this is coulombs. All right, so that would be our equilibrium. All right. Now, on the flow of the line here, of course, for any value between 0 and that equilibrium value, we have a positive derivative, right? Q prime is positive. And for any value greater than this equilibrium value, the derivative is negative. Q prime is negative. So we can use this to sketch a solution. So let's do that. Let's see. We'll do something like this. And let's just... Now your homework will have a bit more variety because the logistic equation is a bit more interesting. This is Q versus T now. So if you were to say start at 0, that would be the greatest rate of change that you would have. All right, so you might have some really steep change, but it levels off as it approaches the equilibrium. If you started halfway, well, you'd have a more shallow approach. If you start very close, it's even more shallow. So that initial rate of change, that initial slope, that initial steepness, I'm getting by this distance here. And it's the same on the other side. So there's a symmetry to these solutions. Because the line has constant slope. So there's a bunch of solutions for different values of Q. Now, let's see. So this is a good place to stop. This covers the first couple paragraphs, roughly. The next video, I'll look at this equation with just letters in it. We'll talk about that.